Alright, let's talk about the minimum cost to connect all the points. So you're given an array of points representing integer coordinate of some point on the 2D plane, where points are equal to xi, yi. So you have to find out the cost of connecting two points between these two. So this is the Manhattan distance between xi minus xj plus yi plus yj, and you definitely need to absolute for both of them, right? Now, you have to return the minimum cost to make all the points to connect, right? So in this solution, I'm going to just quickly draw a diagram. So you want to find out this is a shorter distance, and this is a shorter distance, this one and this one, right? So how do you actually know that, right? So the idea is, well, you set every length, the age should be infinity for everything, right? And then now you have to set a default for the first point. So it doesn't matter like which one is the first point. You have to set the first point in the array to be 0 for the minimum distance. Then when you traverse for the rest of the point, right, you will find out the points between this one with this one, or this one with this one. All right, this line doesn't. This one with this one, or this one with this one, or this one with this one, this one with this one, and so on, right? And this one with this one, this one with this one, this one with this one, right? And just keep going, right? And then this one with this one, this one with this one, and you definitely know this one and this one, right? So just keep traversing, and then you will find out the minimum cost for each edge. And when you find out there's a value less than the default value that I set to infinite, I mean, which is integer the max value, but if there's a value that's less than this value, right, then I can reassign, and I will set this current connecting point to this one. So what I do is I have a Boolean array. So I have a Boolean array with size of n, and this is actually declared did I visit this node or not, right? And then for every single node, when I traverse for the rest of the node, right, I will find out the minimum cost age with the other node, and then I will set that equal to true at the end. And then I also set the minimum age for that age to be let me say x, and probably cost of 1, right? And then I will just keep going, and this is pretty much the solution, and I will just dive into the question, and here we go. So what I do is I have an n, which is the point start length, right? I have a minimum cost, I say equal to 0, and I also I have the age of use equal to 0, right? So I have to return minimum cost, right? So this is what return the minimum cost to make all the point connects, right? So for every single age that I'm gonna add, I'm gonna add every single the minimum age between these two nodes now, right? Now I'm going to have a boolean. I'm going to set the visit equal to new boolean size of n, right? Now I have an array. I'm going to call min distance is equal to int in array, and I say size of n, right? Then for every single default value, for every single point default value, the age for the current node should be infinite, right? So for I equal to 0, I less than, and I plus plus. Now I would say min this at I equal to integer the max value. But I need to know where I should start, right? So I should start at the first point in the point array, right? So then we'll say min this at first point is actually equal to 0. Now I need to traverse the rest of the point. So the best way is what? The best way is if I keep track of the age used, if age used is less than n, I will just keep traversing, and that would be like a queue, right? You know, you just pushing your queue, and then to find out if this point is used or not, right? So this is an idea. I'm going to keep track of the point which I use, and this is a total point, right? So I have a current. So current not equal to -1, right? For right now, because I didn't know which one I'm going to connect. I'm going to set the current minimum age, right? Distance doesn't matter. Okay, so it's going to be integer.max value. So I'm going to set my current point and then current minimum distance. Now I'm going to traverse the point. So I'm going to call node. I'm going to start from 0 to n and then node plus plus. So what I will do is I'm going to find out if I visit this node or not, right? So if I did not visit, at this node, and also the minimum distance at this node, right? Which is greater, which is less than the current minimum distance. So which means I find out there's another point which I can connect, be honest, right? Because I didn't use the other point, and then the edge is actually less than the, and then edge is less than the current minimum, which is I say equal to default value, right? So the first point is going to be 0, 0, right? So I will definitely start at this one, right? If I didn't use it, if I did not use it, I'm going to set my current node equal to node, right? And I'm going to update my minimum distance node, right? To current minimum distance equal to minimum distance node, right? So definitely I'll start it from 0, 0, right? Starting from 0, 0. And then after the for loop, I'm going to just keep adding the minimum cost, keep adding the distance which I found, right? So it's going to per minimum distance, right? The distance I already found, which is supposed to be 0 beyond, suppose, because I didn't traverse rest of the point yet, but I was set. So I set the point 0, the first point in array, because the first point in example 2 is not starting from 0, right? It's starting from somewhere, 3 and then 12, right? And then if I use this point, right? I'm going to call visit current node equal to true, right? And then I would need to do one more thing. If I use this point, I'm going to increment my edge use, right? All right, so now I need to traverse rest of the point. So I don't care which one is going to be first, but here's it. So in next, no, equal to 0. Next, no, less than n. Next, no, plus, right? Now I need to find a weight, right? So using the formula, this is called Manhattan distance. So I'm going to be what? Method absolute, right? And then I'm going to say points at what? Current point at 0 minus points at next node at 0. Come on, next node. Next node should be this. And then I need to plus my y, right? Let me just copy and paste, sorry about that. And this will be 1. This will be 1. Alright, so if I find out the weight, and then I need to know if I visit or not, right? If I did not visit at the next node, and also my minimum distance at the next node is actually what? It's actually greater than my weight. Then I need to update, right? So minimum distance at next node is actually greater than my weight. Then I will just keep updating. So I will definitely start from the first point in array, and then I will traverse for rest of it, right? So after this for loop, they are no longer infinite. There should be some value like calculated by the weight, right? And then afterward, I will just keep updating, right? So I'm not going to set visit next node equal to true, because there might be a point in this for loop, which has the smallest weight, right? So I'm going to just keep track of this. So I'm going to minimum distance next node equal to weight. Then I will traverse at the end of the for loop, and I will back to here, because this is definitely still less than n, because I only say one node equal to true, right? Then I will traverse the next following node, and then here we go. So let me submit. I made an error. New in, sorry. All right. So minimum distance Let me see if I have any other problem. Integer dot max value, okay. And then points at current. Current no, sorry, current no. Where's current no? Current no. Alright, here we go. So let me submit. Sorry for making a typo, but you definitely maybe catch my typo already. But this should be a current node because I already updated a current node. So here we go. So let's talk about time and space. So this is going to be what? This is going to be an all of n, right? For inside all of n, inside this while loop, right? You will traverse all of n as well. This one is all of n as well. So it's going to be n squared for time, right? And then for the space, this is all of n, right? And this is all of n as well. So it's going to be all of n for the worst case. All right. And this is the solution. And this is actually Prim. It's called Prim algorithm. And then you will definitely just go through Wikipedia, just probably just read through it. But this is a little bit slightly different because we already update the value for other node after the first traversal. And somehow they will, I mean, in general, the Prim algorithm, I'm gonna just write down Prim algorithm. Somehow the Prim algorithm is actually say every other node to infinite, and then when it traverses the first point, this one will just connect to the closest point, and then the rest of the points should be infinite as well. And then this one will be say equal to some value, and then this value will just expand. So this is called minimum spanning tree. And then this is the solution, and I will see you next time. Bye.